What's going on, math people? We're back, and this time we're talking about inverse trig derivatives. All right. Now, I took this screenshot of this layout because I feel like this is a tool that you should know how to use. Some people say you need to memorize these and commit them to memory. Hey, to each their own, okay? I need you to know how to use the tool. All right, so inverse trig derivatives. There are 6 inverse trig functions. Therefore, there are 6 inverse trig derivatives. All right, and the layout is down here below. I feel like this is the best one to focus on, specifically because it shows that the chain rule is necessary. A lot of other images have x inside of the function and does not refer to the chain rule. The chain rule is necessary. That u prime in each of these derivatives is representing the chain rule taking place. So let's just hop into an example and utilize what we have. First example, we have y equals cosine inverse of 9x to the fourth. Go to our tool and apply what we have. We want to find dy dx. Dy dx is equal to, the trig function of focus is the cosine inverse function, so I'm going to go to that second column, first unit, right there, and we have negative, I'm going to say negative 1 over the square root of 1 minus 9x to the fourth squared times, this is the u prime, the derivative of 9x to the fourth, which is 36x cubed. There, my friends, you have the derivative of your inverse trig function. I know, too easy. All right. Let's toss in another example. They're not going to get any harder. They look the exact same, okay? Let's just change up which function we want to use. We have y equals sine inverse of square root of 5t. We want to find dy dx. Dy dx. Which tool do we need to refer to? Sine inverse. I have 1 over the square root of 1 minus u squared, 1 over the square root of 5t squared times the derivative of square root of 5t. That will leave me with square root 5. Final answer, square root 5 over the square root of 1 minus 5t squared. Okay. And it doesn't matter which function you use, right? You refer to the tool, make sure you can use the tool. Last and final example, because knowing how to use the tool here is key for me. Committing those functions to memory, that's key for you. All right, so we have last example, y equals cotan inverse of the square root of 3t. Find the derivative, dy dx equals, up there I have negative 1 over 1 plus square root of 3t squared times the square root of 3t. That would be the square root of 3 times 1/2 times t to the negative 1/2. Where did all of that magic come from? Right here in the red. Just notice that cotangent inverse of square root of 3t is the same thing as saying square root of 3 times t to the 1/2 power. And then apply the power rule on the t. And you'll get your final answer of negative square root 3 over 2 square root t times 1 plus 3t after simplification. Alright, my math people, shoot me your questions, shoot me your comments. As always, stay geeky.